Hi students, chemistry is easy when we understand and learn. Today we are going to see a topic, corrosion. It is a small topic in CBSE. Let us see what it is. What is corrosion? See, until now we have seen metallurgy, right? In metallurgy, when metals were observed in nature in what form? In the compound form, in the combined state. Okay, metal in a combined state will be called as corroded metal. Okay, metal in the metallic state will be called as reduced state or the metallic state, right? So what is corrosion? When a metal is attacked by its environment, surrounding materials, surrounding chemicals. When a metal is attacked by its environment, just like moisture, acid, etc., it is said to corrode. It is said to corrode means it turns into its metallic compound. If a metal is turning by nature into metallic compound slowly, then we call it as metal is corroding. So metal undergoes to form metallic oxide. The process is very slow. Okay, it's a very slow process, and then we call it as corrosion. And reverse, metallic compound to metal, then we call it as metallurgy. We call it as metallurgy. In nature we found only metallic compound because that is natural, right? We reduce it to metal and we use this metal. The process of metallic compound formation is very slow, so we are able to use this metal. Let us see example. Silver article turns black on exposure to air. You can see at home silver article turning black, right? What is that reaction? Silver reacts with sulfide in nature and forms silver sulfide. Okay, so that is tarnishing. It forms a coating on the surface alone. Silver is a noble metal, so there is no fast reaction, but the surface of the silver you get tarnishes and turns black. It is silver reacting with sulfur to form silver sulfide, which is only on the surfaces. Okay, copper reacts with moist carbon dioxide to form green color substance. Okay, when we use copper, we can see a green layered substance, okay, on the surface. What is it? It reacts with carbon dioxide in the air. See, each metal reacts with different elements from the different compound or element from the air, and copper reacts with carbon dioxide in the presence of moisture to form copper carbonate, okay, and copper hydroxide. See here we have oxygen also involved, so in the air it takes up three compounds. It takes carbon dioxide, it takes oxygen, it takes moisture and copper, and it forms copper carbonate and copper hydroxide, right? Then when iron is exposed to moist air, brown flaky substance called rust is formed. This is the metal which is more bothering. Compared to silver and copper, iron is less highly reactive or less noble. The other two are more noble. The reaction is very slow. But when it comes to iron, the reaction is very slow. But compared to noble metal, iron is rusting faster, and we use iron is available in abundance. We use all engineering aspects with iron because it finds very high strength also, and it is found to be undergo rusting. We'll see what is rusting. Rusting is iron with moisture with oxygen. So two compound involved. One is element, another one is compound. Yeah. So here iron with moisture and oxygen, it forms iron oxide and XH2O. This is called rust. This is the formula for rust. Fe2O3, ferric oxide with XH2O, right? Okay, this is rust, and it is the brown flaky substance. What happens after some times, this brown flaky substance is removed off and the fresh surface is exposed to air, again corrosion starts take place. Okay, in the other two metal, it is not happening. Only the topmost layer gets corroded. Bottommost, there is no corrosion. But here, it will be topmost layer initially getting corroded, and after some time, this layer gets removed off and fresh layer is exposed. Again, it continues the corrosion. So, it is much botheration, right? How to prevent this? How to prevent this corrosion? See, we spend so much of energy and money to get the metal, right? And metal without spending energy, energy and money, it turns out to be its oxide state. Okay, it's in combined state. So what to be done for that? How can we stop the corrosion process? Right. So first is surface treatment. So we can give surface treatment. See, where is the problem? The surface is exposed to the environment, right? So when the surface is exposed to the environment, the reaction takes place. If I cut off the surface from the environment, there is no corrosion, right? Yeah. So what we do, we apply paint on the surface, so there is no, metal is not in contact with the environment, right? So paint, we can apply paint on the surface. We can oil the surface. See, oil cut off the moisture. Oil cut off the environment. Okay. And greasing. Greasing also removes the, reduces the corrosion. Galvanizing, it is a technical term. We'll see what is galvanizing. Chrome plating. Again, it is painting. It is chrome plating. On the surface, we give chromium plating. Anodizing. Okay, we make the surface anode. Okay, we know that only the reaction is on the surface. Okay, and if it is not getting removed, what I can do? I myself anodize the surface so that inner metal is protected. Or alloying. I can make, instead of having one single metal, I will alloy the metal so that it does not corrode. We'll see these two in detail. Galvanizing and alloying in detail. What is galvanizing? See, galvanizing is giving a coating on a metal. Consider this is your metallic surface. Giving a coating on the surface with a less noble metal. See, if this is iron, okay, and this could be zinc. Zinc is less noble metal. Iron is more noble metal compared to zinc. I give a coating of zinc over iron. Then I call it as galvanizing. Why? Less noble metal means highly reactive metal. So when this highly reactive metal is exposed to the environment, it will start reacting. Right? Then why I have to give such coating? Yes, there is an answer. See, when this zinc is exposed to the environment, definitely zinc will react, but iron will be protected. In the presence of zinc and iron takes the role of cathode. Cathode is always protected and zinc takes the role of anode. Okay, so anode only corrodes, cathode is protected. So even in small area, see, consider I have a metal like this. In a certain area, there is no zinc. Zinc is removed. Now see, iron is exposed here. Even if iron is exposed, it will not corrode. Why? The zinc is anode and iron is cathode. A cathode will never corrode. Only zinc will corrode. So that is the benefit. If I do a different thing, if I give a noble metal coating, if that such opening happens, then iron will start corroding and we call it as spitting corrosion. That will take place. So that is not required. So I give galvanizing. Less noble metal being coated on a more noble metal to avoid corrosion on the more noble metal. That is iron. I want to avoid corrosion on the iron. So zinc surface is given. Right? Good. Then what is alloying? Alloying is homogeneous mixture of two or more metal or metal and a non-metal. So it is a combination of number of metals. Okay, or it is a combination of metal and having a non-metal also, right? We'll see example. See here, metal plus metal is alloy, metal plus non-metal is also alloy. Okay, at least one ingredient should be metal, then we call it as alloy. Alloy is nothing but solid solution, homogeneous solid solution. Throughout it is same. Okay. Let us see preparation of an alloy. How an alloy is prepared. Take a metal, okay, major metal, heat it, take it in the molten state. Liquid statement, it is molten. Generally, metals are taken in the molten state. Metals melts at high temperature, right? That too noble metals, okay. So, metal in the molten state, add another metal, okay, metal or a non-metal, which is dissolved, okay. So, we add another metal or a non-metal which dissolves in this metal. Okay, mix well, then allow it to solidify. We get alloy liquid, then cool it, we get alloy solid. That's it. Processes, that's it. But we need to melt it and then add the another metal which should dissolve into it, okay, and it forms alloy liquid, and then on cooling we get alloy solid. Let us see examples. Amalgam. Amalgam is alloy of mercury. Okay, a common name amalgam is given for alloy of mercury. So that is an example. Then we have an example, any metal. Okay, mercury with any metal we call it as amalgam. Okay, we can add any metal to it, we call it as amalgam. Then next example, brass. What is brass? Copper plus zinc. In copper we add zinc. Okay. Another example is bronze. Again it is an alloy of copper. Copper plus tin. Okay. These two are, see, copper is a very good conductor, but when I am alloying it, it changes the property. It is not as good as copper. Zinc and tin, when it is added, it is not as good as copper. So it is not a good conductor of electricity. After alloying, I cannot use it for current flow, right? Solder. Solder is another alloy, very important alloy. Lead and tin, okay? It is used for easy melting. Okay, I want to fix the electronic material using this lead and tin. It is a conductor, okay, but it melts at very low temperature, used for melting electrical wiring, welding electrical wiring. So it is fixing the electronics item into the printed circuit board. So all those things we use the solder. Okay, it easily melts. Okay, lead and tin in combination. So we have seen amalgam. It is an alloy of mercury. Brass and bronze, it is an alloy of copper. Solder, it is an alloy of lead. Okay, and we have gold. 22 karat gold consists of 22 parts of gold and 2 parts of copper or silver. Why this copper or silver is added? To improve the strength. Okay, improve the strength of gold. To improve the strength of gold. So only after adding silver or copper to the gold, it gets strengthened and we can make use for making jewelry, and that jewelry will be stronger. Okay, then we have 24 karat gold. What is that? It is pure gold. Okay, and it is very soft. Okay, it is very soft. It is very soft in nature. So we cannot use for making jewelry. Into that, if I add this, then I can make jewelry, and which will stay stronger for long time. Okay. Hope so you have understood. Thank you. Let us meet in another class.